Hi everyone, this is Mrs. Snowbeck. Today we are going to do Unit 2 Notes 2. We're going to talk a lot about slopes of lines and rate of change and graphing lines. So if you're a skier or a snowboarder, you know that ski resorts rate their trails by the difficulty level, and a primary factor in that rating is going to be the slope of the hill. So generally, the easier trails have a slope that range from 6% to 25%, and the more difficult trails have a slope of 40% or greater. I think those are like the black diamonds or the double black diamonds. So when you think of slope, there's a little catchphrase for remembering what goes on the numerator and what goes on the denominator, and it's rise over run. So go ahead and fill that in here, rise over run. Slope is basically the steepness of the line, and like I said, you can find it by counting the rise over the run. So I always start at the point on the left. If I wanted to find the slope of this line, I would start at A, and I would figure out how much do I have to go up or down to get over to B, and then how much do I have to go left or right. So in this case, it looks like I'm going to go down 3, and then I'm going to go right 6. Now down 3 is the same as -3, right 6 is the same as +6, and this can be reduced to -1/2. That is the slope of your line, and you can check it if you count down 1, right 2, down 1, right 2, down 1, right 2. Yep, I keep landing on the line, down 1, right 2, so that is a good description of the slope. Now there's a second way to find the slope of a line, and it's using a formula. And maybe you remember the letter M representing slope. The formula goes like this. It's y2 minus y1 over x2 minus x1. And it's basically the change in the y values over the change in the x values. So first thing we have to do is we have to figure out where they're located. So figure out what's the coordinate at A. And to me, it looks like it's from the origin right here. It looks like it's left 2 up 3. So I think it is -2 +3. Left 2 up 3. And for B, I think it is, if you count, it looks like it's 1, 2, 3, 4. I think it's right 4 up 0. Again, you can kind of check that and count them on your own. But now let's plug them into the formula. The change in y's would be 0 minus 3. So I take the second number here minus the second number here. And then on the denominator, I do the x's. So 4 minus -2. On the top, I get -3. On the bottom, I get 6. This reduces to -1/2, which is the same thing I got when I did the counting on the squares. Positive slopes are going to go uphill from left to right. So if you had a little picture, of a coordinate plane, an example of a positive slope or a line with a positive slope might look like this. Over here on the left, you're down here and you're working your way up the hill as you go to the right. Negative slopes go downhill from left to right. So a line that might have a negative slope might look like this, where on the left it starts up higher and then it works its way down as it moves to the right. Take a look at number 1. Does that have a positive slope or a negative slope? It has a positive slope. That means our answer should be a positive number. It might be a fraction, but it will be a positive number. I'm just going to put a little note here. This is a positive slope. And then I think since it's graphed so nicely, the quickest way to do this is count rise over run. So remember, start at your point that's on the left. In this case, it's J, and figure out how much would you have to go up and how much would you have to go over. In this case, it looks like we're going up 1, 2, 3, 4, 5, so 5. And then we're going to go over 1, 2, 3, 4. So the slope of this line is 5/4. On number 2, does this have a positive slope or a negative slope? it has a negative slope. It's going downhill as it goes from left to right. And again, if we use the counting method and we start on the left at L, how much do we rise? Well, we're actually going to drop this time, but that's okay. So how much did we drop? 1, 2, 3, 4, 5, 6. So we dropped 6, and then we ran 1, 2, 3. So we went over 3. This can reduce to -2. If you want to think of it as -2/1, that's okay, but usually we write our final answer as just -2. Notice we got a negative number. It has a negative slope. In number 3, I would describe line NP as a horizontal line. So I'm just going to write that also. This is a horizontal line. And if you're trying to find the slope, think about the counting method. As you think about your rise over run, how much does it rise as you go from N to P? Well, it doesn't rise at all, so 0. How much does it run? 1, 2, 3, 4, 5, 6, 7. 0 over 7, if you get 0 of the 7 candy bars, you get 0. So the slope of a horizontal line is 0, and that's true for every horizontal line. They have no slope or a slope of 0. Number 4, this is a vertical line. And if you use the counting method, it's kind of strange. If you start at, let's just start at R, and we want to go to Q. And so we're going to rise 1, 2, 3, 4, 5, and we're going to run 0. We're going to not move over at all. A little bell should be going off in your head right now, like ding, 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 something's wrong. You can never have 0 on the bottom of a fraction in math. It's like illegal. Think if you have 0 candy bars, is there a way you can have 5 of them? No, it's impossible, right? And so what we say for something like this is we say the slope is undefined. And that's your answer for every vertical line. The slope is undefined. Lines B and R are parallel. Line B passes through 3, 6 and -9, 2. Line R passes through 5, 4 and 2, 3. Find the slope of B. Let's use the formula. Remember our slope formula is y2 minus y1 over x2 minus x1. Why don't you guys pause the video and try to find the slope of both of those, B and R. And then unpause the video when you're done with those two. So here's my first slope. I did the change in y, so I did 2 minus 6, and then over -9 minus 3. And I ended up with 1/3. Now I'm going to do the next one. So I'm going to do the y's, so I'm going to go 3 minus 4 over 2 minus 5. I get -1 over -3. Two negatives make a positive, so I get 1/3. So what I want you to notice here is it says B and R are parallel. I can tell that because of the two slopes I got. Parallel lines will have the same slope. All right, let's go over to the other example here. It says lines S and P are perpendicular. Will you please pause the video and try to find the slope of S and the slope of P, and then unpause? So here's what I got for the slope of S. I got 3, and now I'm going to do the slope of P. So remember, it's going to be the change in y. So I'm going to do 1 minus 2 over 6 minus 3. I end up with -1 over 3, which is -1/3. These lines are definitely not parallel because they do not have the same slope. So what I want you to think about is the 3 over 1 and the -1 over 3. Those are inverses of each other, opposite inverses. So if I take the 3 over 1 and I flip it to 1 over 3 and I switch the sign, these two slopes are perpendicular to each other. Remember, perpendicular means they meet at 90 degrees. So two lines have the same slope if and only if they are parallel. Parallel lines have the same slope. And two lines are perpendicular if and only if their slopes are opposite inverses. or opposite reciprocals. All right, I'm going to have you guys try number 5. You're going to find the slope of R and you're going to find the slope of S, and you're going to try to figure out, are those two lines parallel, perpendicular, or neither? So find the two slopes and then compare them, and then unpause when you're done. All right, slope of R is 1 minus negative 9 over negative 4 minus 7. This is 10 over negative 11. The slope of S is negative 4 minus 6 over 15 minus 4. This is negative 10 over 11. When you look at these, the 10 is on top in both, the 11's on the bottom on both. The negative sign is not in the same place. Does that matter? The answer is no. It doesn't matter if the negative's on the top or the bottom or out front. These are the same. It's negative 10 elevenths. And so the answer is these lines are parallel. So we could say S is parallel to R. Now let's get into graphing some lines. Graph the line that contains the point negative 3, 0, and is perpendicular to the line that contains the points negative 2, negative 3, and 2, 0. All right, I'm going to break this down. Let's do this in steps. So step number 1 is I want you to graph the point. So in this case, you're going to graph negative 3, 0. So put a dot at negative 3, 0. Should be right there. Now our line has to contain that point. So our line ultimately has to go through that point. Step number 2 is let's find the slope of the line that goes through the other 2 points, because it has to be perpendicular to the line that contains negative 2, negative 3, and 2, 0. So next we're going to find the slope, and the way that I'm going to do that, I'm going to use these 2 points. And so I'm going to do 0 minus negative 3 over 2 minus negative 2. These minus a minus change to a plus. And so we wind up with 3 over 4. That's the slope of the line that goes through negative 2, negative 3, and 2, 0. Next, we have to graph the line that goes through the point negative 3, 0, which we have a dot at, and it has to be perpendicular to this one, perpendicular to this one. So step number 3 is we're going to get the perpendicular slope. So in this case, we flip it and switch the sign. That's our perpendicular slope. And then fourth, we're just going to go from our point, we're going to count down 4 and right 3. I always put the negative on the top number. It doesn't really matter, but I always just put it on the top. So remember, it's rise over run. This is our rise. It's actually a fall. And this is our run. So from our dot, we're going to go down 4, 1, 2, 3, 4, and we're going to go to the right 3, 1, 2, 3. This is going to be our other point. You can connect them. And that is the graph of the line that goes through the point negative 3, 0 and is perpendicular to the other line. If you wanted to, you could plot these 2 points. I'll do it real quick. Negative 2, negative 3 is right here, and 2, 0 is right here. And if I just kind of graph that in there, do they look like they're perpendicular? They do. To me, they look like they cross at 90 degrees. Graph the line that contains the point 5, 1 and is parallel to the line that contains negative 2, 4, and 2, 1. So step number 1 is plot the point. So 1 is graph the point 5, 1. Okay, so I'm going to do that. It's right here. Step number 2 is find the slope of the line that goes through the other 2 points. So I'm going to do y minus y. So I'm going to do 1 minus 4 over 2 minus negative 2. I wind up with negative 3 over 4, negative 3/4. Step number 3 is our line has to be parallel to that one. So what is the parallel slope? Well, it would be the same. It's -3/4. If two lines are parallel, they have the same slope. And then finally, from our point, you have to count the slope. So count out down 3 and right 4. So down 3, 1, 2, 3, and right 4, 1, 2, 3, 4. Uh-oh, goes off the graph. If that happens, you can reverse your counting and you could go up 3 and back 4. That's kind of a cool little method. There is our line. It goes through the point 5, 1, and it's parallel to the other line. Now, if you wanted to, you could check it. Put your points at these other two locations. So -2, 4 is right here, and 2, 1 is right here, and graph that in. Does it look like they would be parallel? Yes, it does. A highway on-ramp rises 15 feet for every 100 horizontal feet traveled. What is the rate of change of the ramp? So this is a really important phrase, rate of change. I want you to write this down. Rate of change equals slope. Whenever you see that, it basically means find the slope. Now remember, slope is rise over run. So in this case, it rises 15 feet for every 100 feet that it runs. And then, of course, you should simplify. So 5 goes into both of these. 5 goes into 15 3 times. 5 goes into 120. So for every 3 feet horizontal or vertically, it will run 20 feet horizontally. You're doing good. This is a long note session, I know. In 1965, the city of Columbia had a population of 85,000. In 2010, it was reported the population of Columbia was 100,000. What is the annual rate of change? Which means slope. By the way, there is a city called Columbia. It's in South Carolina. At first I was like, city, that's a country, but there is a city. Here's what I do. I take the information and I put it into coordinates. In 1965, the population was 85,000. In 2010, the population was 100,000. Find the annual rate of change. That means how much did the population increase each year on average? Now just do the slope, the rate of change. Y minus Y, so 100,000 minus 85,000 over X minus X, 2010 minus 1965. Okay, simplify. So you get 15,000 over 45, divide, and you get 333.3 repeating. So in other words, it went up approximately 333 people per year. That was the annual rate of change. You're not going to have a third of a person, so I rounded. Number 10, Part B. If this trend continued at the same rate, how many songs were legally downloaded in 2010? Well, you guys, we know in 2006, there were 500 million songs legally downloaded. And isn't it going to go up by 150 million per year? Well, 2010 minus 2006 is 4 years. And so what I would do is 150 times 4. 150 times 4 is 600. Then you need to add that amount to what was being legally downloaded. So your final step would be 500 million plus 150 million more times 4 years is 600 million. So add those together and it's going to be 1,100 million songs in 2010 were legally downloaded. There's other ways to do this as well. You could use the slope formula. Hey, we're almost there. Number 11. In 2010, the annual sales for one manufacturer of camping equipment was $48.9 million. In 2015, the total sales was $85.9 million. If the sales increase at the same rate, what will their total sales be in 2030? Okay, here we go. Take your information, put it down as coordinates. In 2010, 48.9 million. In 2015, 85.9 million. So maybe this is like REI or Gander Mountain or something. And then the next thing we have to do is figure out, well, what was their annual increase or their annual rate of change during these 5 years? And then once we know that rate, we can figure out how much they're going to earn in 2015. So next, find the slope between these 2 points. So 85.9 minus 48.9 over 2015 minus 2010. I believe we get 37 over 5, which is approximately 7.4. And that's how much their sales increase per year. So it's 7.4 million per year more than the year before. Okay, so next, from 2030 to 2015 is 15 years. And each of those years, it's going to go up by 7.4. So 15 times 7.4, I'm going to type that in my calculator here. So 15 times 7.4, 111. So now here's the trick. In 2015, this is important, they were selling 85.9 million. So we have to take, for our final answer, we have to take the 85.9 million and add the 111 million to it. So I have to add what I was selling. And we get, let me try that one more time, 111 plus 85.9, yeah, 196.9 million, and let's just see, yeah, $1 million in annual sales in 2030. Oof, that's a lot of money. This last slide is not in your notes, but it's really important you know how to do this for the quiz. So please pause the video and think about, if you have a slope of 2/3, what's the slope that's parallel to that? And what's the slope that's perpendicular to that? And then go down the list and just see if you can think through it. You don't have to write it down anywhere if you don't want, but just think through this. So here's the answers for the first 4. Remember, parallel slopes have to be the same, so I didn't change anything for those. And then perpendicular, you flip it and switch it. You take the opposite inverse. Finally, what about if you have a slope of 0? Remember, what kind of line is that? Horizontal line, and all horizontal lines will be parallel and they'll all have a slope of 0. And then a perpendicular line, wouldn't that be a vertical line? And what is the slope of a vertical line? This is the weird one. It's undefined. All right, you guys, try Unit 2, Practice 2. Message me with questions. Have a great night.